Chapter 1, Section 5 is about solving miscellaneous equations. All that means is there's going to be some equations that maybe are less typical than the kind we've already discussed. So instead of quadratics, maybe you'll see some third-degree polynomials that you can solve using traditional methods, and things like that, radical equations and stuff. So let's get into solving some of those. Here are two third-degree polynomials. These are cubics. Something that's very important to note here is that we haven't talked about polynomials yet and how you go about solving polynomials of degrees higher than 2. We've pretty comprehensively covered how to solve any quadratic equation. But when we have a polynomial that's has a degree greater than 2, it's not always the case that we can easily solve it by factoring or by doing anything like that. There is a cubic formula, but it's complicated and not typically taught. That being said, there are quite a few different kinds of, especially third-degree polynomials, cubics, that we can solve by traditional means. And here's two examples. So the first question here is 8x cubed minus 27. And right away, what you have to recognize for this problem is that this 8x cubed is 2x cubed. And this 27 is 3 cubed, of course. So what we have here is what's known as a difference of cubes. And this is a known factorization. The standard for this is a minus b. A cubed minus b cubed. This factors to a minus b times a squared plus ab plus b squared. And this is kind of I wouldn't say this is something you should memorize, but it's something you need to know exists so that you can refer to it and deal with when you're presented with a difference of cubes like this. So if we consider this, and then that means that a would be 2x and b would be 3, essentially, we can write out the factorization for this. So it will be 2x minus 3 times, then we have 4x squared, because that's 2x, squared, just 4 squared, so 2 squared and x squared. And then we'll have 2x times 3, so plus 6x, and then just 3 squared, so plus 9 equals 0. Okay, now by using the zero product property, we can see that 2x minus 3 could equal 0. So when you solve for x, you'll get 3/2. So 3/2 is one of our answers. Now, unfortunately, the next part of this is difficult because we have 4x squared plus 6x plus 9 could also equal 0, and this does not factor nicely at all. So that's okay though, because we can solve any quadratic using any of our methods. I'm going to go ahead and show completing the square here though, because I feel like it's always good to review how to do that. So the first step I'm going to do in the process of completing the square is to subtract 9 from both sides, and I'll have 4x squared plus 6x equals negative 9. Equals negative 9. Okay, now I don't want this 4 in front of the x squared term, so I'm going to factor the 4 out. So when I do that, I will have 4 times x squared, and then if I factor a 4 out of a 6, I'll be left with 3/2. 6 fours, so 3/2. So 3/2 x. And then I'm going to leave a little space because I want to complete the square inside this parentheses. In order to do that, I need to look at this middle term of 3/2 and divide it by 2. 3/2 divided by 2 is going to be 3/4. But then I'm going to need to square that. And we get that from the idea that a plus b quantity squared is equal to a squared plus 2ab plus b squared. So in other words, this 3/2 represents right now this 2a, or actually this 2b really. It's kind of confusing when you have the two variables. So we need to divide it by 2 to get what b would be in order to then square it to get b squared. So 3/2 divided by 2 is 3/4. Squared would be 9/16. So we need to add 9/16 right here. Okay, now this is a very tricky step here. If students make mistakes, this is kind of where it happens. We just added a value of 9/16 within these parentheses, but that's not the value we added to the left side of the equation. We added 4 times that to the left side of the equation because of that 4 outside the parentheses. So what we really did was we added 9/4, because 4 times 9/16 is 9/4 to the left side. So that means we have to add 9/4 to the right side as well. So let's clean some things up here. Now we have 4 times x, and then the whole point of writing it out like this is that we can change this to say 3/4 squared. So 4 times quantity x minus 3/4 squared equals, now we can do this real quick too, because -9 is the same thing as -36/4. So I'm going to add -36/4 and +9/4, and I'll get -25/4. Alright, now we're going to divide both sides by 4 to get rid of this 4 over here. It's called the division property of equality. And so we're going to be left with this. The quantity x minus 3/4 squared is equal to -25/16. Okay, we can now square root both sides, and you might see red flags because of this negative sign, but that's okay. We know how to deal with that. That's just an imaginary number. So what we're going to have is x minus 3/4 is equal to plus or minus 5/4 I. I skipped a few steps there, okay, but like that's fine. Something that you should know is we have wait, did we do this right, or did I mess something up? I think we're okay here. I feel like we're doing this right still. Let me pause it to make sure. Oh, sorry, I see what I did. We gotta back up a few steps here. This 25, I always have this mistake when I take 36 minus 9, I get 25 instead of what it really is, which is 27. So this is really -27 fourths over here. And then we divide by 4, we get, sorry about that, we get this. We'll have x minus 3/4 squared is equal to -27/16. Okay. Now, if we square root both sides, take the square root of both sides here, there's an intermediate step where, and I'm just going to write this up here because I want to keep things simple where we're actually solving it. This will be the absolute value of x minus 3/4 is equal to the square root of -27/16. And then what we typically do is we sort of just forget that this is a thing, even though it is, and we say x minus 3/4 is equal to plus or minus the square root of -27/16. Carry on like this. This here is I times the square root of 27/16, and then you further simplify the square root. But we're skipping that step for now, and I'm going to go straight to saying that x minus 3/4 is equal to I times the square root of 27 divided by 4, because the square root of 16 is 4. Okay, now 27, let's do another step. X minus 3/4 is equal to I times 3√3 divided by 4. And we have a plus or minus out here in front. We forgot the plus or minus. And then so to answer the question, then x will equal 3/4 plus or minus I times, or we can actually write this, 3I times the square root of 3 divided by 4. So that would be the answer to that. Now it's the answer to just this part of it. We have our original answer of x equals 3/2 over here. So to solve this, we would write it as a set where we have 3/2 and 3 plus or minus 3i√3 over 4 as our 3 solutions to this third variable polynomial. It takes a long time to solve this problem because of the unfortunate situation with that factorization. This next problem, although it even looks even more complicated, really isn't. We're just going to look at these first two terms and we're going to see what's the greatest common factor. It's 4x squared. What's left over would be x plus 3. Then we're going to look at these two terms. The greatest common factor is -9, so left over is x plus 3. Now if we look at these two terms, x plus 3 is in common, and left over is 4x squared minus 9. This 4x squared minus 9 is the difference of perfect squares. Remember how that works. A minus b, a squared minus b squared is equal to a minus b times a plus b. So in this case then, by similar thought process to the above problem, x plus 3 would be 2x minus, x plus 3 times 2x minus 3 times 2x plus 3 equals 0. So x for this one would equal -3, -3 halves, and 3 halves. So that one's actually much simpler than the other one. All right, let's move on. Yeah, so radical equations. First of all, I know you're thinking, no, that's not me, I wish. But just a general tip for solving radical equations is we want the radical to be by itself on one side. This isn't always the case, but it does tend to make things more simple. So for this problem, what we have, and what you have to remember about a radical is that 2 minus 3x right now is under the radical, but it's really just an exponent. It's being raised to the 1/2. And we want to undo this. We want to make it to the first power. So we're going to want to raise it to the second power, because powers of powers multiply powers. 1/2 times 2 is 1. So that's kind of the objective here. So for this though, what you usually see is just let's square both sides. Now as soon as you do this, as soon as you have squared both sides or raised both sides to some power, no matter what that power is, you've introduced the possibility that you could have extraneous solutions, meaning that you're going to solve the problem, get an answer, but that answer doesn't actually work in the original problem. So just keep that in mind anytime you're solving a radical equation. So for this one, if we square this, we'll have 2 minus 3x is equal to 81. If we subtract 2 both sides, we'll have -3x is equal to 79. And then if we divide both sides by -3, x is equal to -79/3. Unfortunately, it doesn't simplify and make a nice number there. Okay, so remember now, we want to move the radical to keep it by itself on one side. So for this problem, I'm going to subtract 18 from both sides. So the square root of 3x is equal to x minus 18. And then we're going to square both sides, just like we did in the previous problem. Remember that x is still not the radical there. Okay, when we do that, we'll have 3x equals, and then if we FOIL this out, we'll have x squared minus 36x, and then 18 squared is a number. What would that be? It would be 300, and it would be 380, no, 324. Sorry, can't do math in my head. Okay, now we're going to have, we subtract 3x both sides, and we will have 0 is equal to x squared minus 39x plus 324. It's 324, so if this is 27 and 12, and this is 27 and 12. Okay, so this is going to factor, so 0 equals x squared minus 27, oh sorry, x squared, yeah, minus 27x minus 12x plus 324. Let's go, let me write that again up here. So between these two terms, x is the greatest common factor, x minus 27, and then between these two terms, 12, -12, so x minus 27. So this is going to factor to x minus 12 times x minus 27 is equal to 0. So x could be 12 or 27. Now here we have two answers, but we got to be real careful because we have to go plug this back into our original problem to make sure it works. So if we plug in 12, for example, it will be the square root of 3 times 12, which is 36. So we'll have 6 plus 18. Does that equal 27? It doesn't, right? It doesn't equal 27, so 12 doesn't work. We could try 27. The square root of 3 times 27, that's 81, so it's going to be 9 plus 18. Does that equal 27? Sorry, did that other answer equal 12? No, it didn't. Sorry, I didn't mean to set it equal to 27. Okay, but this one does work, so the answer is 27 and not 12. Okay, another one's here because we have radical equations can be fairly complicated sometimes. So for this one here, we don't want to put the radicals on the same side like this, even though we can. But when you have two radicals, it's kind of better to have them on opposite sides, just so that when you're going to have to do foiling at some point, and it's not so great when you have to foil with two radicals, though you totally can. So for this one, though, we're going to proceed the same way you would expect. We're going to square both sides. Okay, and we're going to hit 2x plus 3 equals, and now it's going to be, if this is a and b, remember how that FOILs, a squared plus 2ab plus b squared, right? So we're going to have x minus 2, that's my a squared, and I'll just put b squared right now for simplicity, 4, 2 squared is 4, plus 2 times this, right, 2 times b, which was 2, so 4 times a, so 4 times the square root of x minus 2. That's FOILed out with a little bit of skipping steps and kind of going in different order. All right, now we're gonna get the radical by itself. So if we subtract x from both sides, and this is negative 2 plus 4 is 2, so if you subtract 2 from both sides, so minus x minus 2, we'll have x plus 1 is equal to 4 times the square root of x minus 2. Now at this point you have a choice, because we're gonna square both sides of this equation, and to get rid of the radical. So you can either choose to divide by 4 here first or later. Either way, you're going to end up with a divide by 16 problem somewhere. I would encourage you here, if your number is decent, like 4 isn't so bad. If you're gonna, I would encourage you to leave the 4, and we'll just proceed through here and show you why. Notice how if I divided both sides by 4 here, I would have x plus 1 all over 4 on the left side, and I'm going to have to square that, which isn't so nice. So let's square both sides right now. And we're going to have x squared plus 2x plus 1 equals, then 4 squared is 16, and then x minus square root of x minus 2 squared is just x minus 2. Now we squared both sides of this equation twice. We've introduced all kinds of potential extraneous solutions. So we got to keep that in mind. So x squared plus 2x plus 1 is equal to 16x minus 32. If we move the 16x and the 32 over, we'll have 0 is equal to x squared minus 14x plus 33. This actually factors to 11 and 3, so x minus 33x, x minus 11x minus 3x plus 33, and x squared, x times x minus 11 minus 3 times x minus 11. We'll have x minus 11 times x minus 3. So we have the zero product property says that x could be 11 or x could equal 3. So we have to check and see if 3 and 11 both work in our original equation here. So we'd say, all right, 2 times 11 plus 3, does that equal this? Well, this is 1, this is 2. 2 times 11 is 22, plus 3 is 25. So does 5 equal, wait, did we screw something up? Sorry. Yeah, we did. I keep screwing that up. This is 11. So 11 minus 2 is 9, so it's 3. So does 5 equal 3 plus 2? Yes, so that means 11 works. Would 3 work? 2 times 3 plus 3 equals 3 minus 2 plus 2. So 2 times 3 is 6 plus 3. So 3 equals 3 minus 2 is 1. Square root of 1 is 1 plus 2. Does 3 equal 1 plus 2? Yes. So both of these work. The answer then is 11 and 3. You can write it like that, or as a set like that. Okay, and then this is the last radical equation we'll do for a little while. We have essentially here, just like we had this square root is like the square root is like the quantity 2x plus 3 to the 1/2. Well, this is like the quantity 2x plus 3 to the 1/3. So we're going to cube both sides of this, and we'll have 2x plus 3 is equal to negative 27. Subtract 3 both sides. 2x is equal to negative 30. X would equal negative 10. Sorry, not negative 2x, 15, negative 15. Yeah, and you could plug negative 15 in back in to check, but it does work, so negative 15 is the answer to that one. Okay, sometimes we're given straight up rational exponents. Now there's obviously a really close relationship between radicals and rational exponents. So if I want to get rid of this 1/3, I'm going to cube both sides, just like we did for that previous problem actually, right? Because 1/3 cubed, like not 1/3 cubed, but if I raise something to the 1/3 and then raise it to the third power, it cancels out basically and becomes to the first power. So this will be y plus 6 is equal to negative 2 times negative 2 times negative 2, which is negative 8. Y equals negative 14. If you plug this back in, you'd have negative 14 plus 6 equals negative 2. It does, right? Negative 8, the cubed root of negative 8 effectively is negative 2. This works out. So we have our answer is y equals negative 14. All right, and this one's a little more tricky now. Okay, so we want to, our objective is to make this be a 1. So what power would I have to raise this to in order to get 1? Well, I want 3/4 to multiply by something to be 1. 3/4 times what equals 1? Well, the reciprocal of 3/4. That would give us 1. So we're going to raise this to the reciprocal power, the 4/3 power. When we do to one side, we have to do the other. So on the left side, we're going to end up with 1/2 w minus 5. And on the right side, we're going to have this weird thing, 8 to the 4/3. Now, kind of the pro tip for this is to always reduce your, if 8 or if whatever number this is some multiple of another number, then you should try to rewrite it. So what we're going to do is say, all right, 8 is the same thing as 2 cubed. So we're going to say 1/2 w minus 5 equals 2 cubed, and now we're raising that 2 cubed to the 4/3 power. Okay, here's what's happening. 3 to the 4/3, 3 times 4/3 is just 4. So what we really have is 1/2 w minus 5 equals 2 to the 4th. 1/2 w minus 5 is equal to 16. 1/2 w equals, I have to add 5 to both sides, 21. Divide both sides by 1/2, with w is equal to 42. And if you plug 42 back in, it'll work. All right, one more kind of problem here. And it's when we have rational exponents, but it's actually not really much of a rational exponent problem. This is in the form of something that looks like a quadratic. In fact, if I just ignored these denominators of these rational exponents, I would have 6x squared minus 5x minus 6, and I could probably factor this. So the key here is A, to take a deep breath and kind of not panic, and B, use substitution. So this is the key, I'm gonna let A equal x to the 1/3, and I'm just gonna show you what happens when we do that. We will have 6a squared, right? If I squared x to the 1/3, I would have x to the 2/3 minus 5a minus 6 equals 0, and we're just gonna factor this like normal now. Okay, this is 2 times 3, this is 2 times 3. If I have a 9 and a 4, I can get a 5, and that's a negative 9 and a positive 4. So 6a squared minus 9a plus 4a minus 6 equals 0. Looking at these two things, this factors to 3a can come out, and we're left with 2a minus 3. Looking at these two things, a 2 can come out, so plus 2, and we're left with a minus 3. Okay, now, sorry, not 2a minus 2a minus 3. 2a minus 3 is in common between these two terms, so 2a minus 3 times 3a minus 2 equals 0. So a could be 3/2, or a could be, it could be 3/2 or 2/3, right? Or we have negative 3/2. Did I screw something up here? No, I think we're, plus, that's a plus right here. So that'd be negative 2/3. Okay, so here's my two things solved for a. But the whole problem, I didn't have a in my original problem. I used substitution here. So I need to go back and resubstitute these things in. So let's do that up here. What I have really is that x to the 1/3 is equal to 3/2. And that x to the 1/3 is equal to negative 2/3. Now we can see that all we're going to need to do here is cube both of these. Okay, and when we're done, x will equal 27/8, and here x will equal negative 8/27. So my answers then will be negative 8/27 and 27/8, and then we're done. So these kinds of problems are fairly typical in pre-calculus. They'll be particularly useful to recognize what's going on here when we start to get into logarithms and exponentials. You'll kind of just be able to move through rational exponents just a little bit more cleanly if you can recognize the power of substitution.